Okay, welcome to Accelerated Math. Solve quadratic inequalities. Okay, I want to kind of give you a little bit of an overview of what we're doing here so maybe you can understand this a little bit better than just some procedures. But if you go back to, I believe about 8th grade, you may have had a problem like this. Well, let's go back to 6th grade then. Okay, something like that. And here's how you solved it. You divided both sides by 4, cancel that out, you got x equals 4, and that was your answer. Then you jump up to 8th grade, you got 4x greater than now, or equal to maybe 16. And you basically treated it just like the equality, except for when you divide by this, you had to figure out whether you were going to flip that symbol over or not. It would depend on if you multiplied or divided by a negative. In this case, we just divided by a positive, so it came out to x greater than or equal to 4. And then you could represent that on a number line. You stuck 4 in the middle somewhere, and you did a closed circle in this case, because it said or equal to, and it said everything greater than that. So you plug it in like this. And one thing you could do with that is you could test something. For example, 10 would be over here, just kind of going past 4 over here. 10 would be over here. If I plug 10 back into the original equation, I get 4 times 10 is 40, and is 40 really greater than or equal to 16, which was the original equation? And yes, it is. Therefore, that's why everything is shaded on this side. So basically what that shading was telling you was that everything in this shaded zone is part of the solution set, and nothing on this side. So if you take 0, for example, and you plug that back into the original equation, it should not come out true. So 4 times 0 is 0, and 0 is not greater than or equal to 16. It's not true, and that's why it's not part of the solution set. All right, now let's fast forward to what we're doing today. And here's the deal, is that it's not just a simple 4x greater than or equal to 21. Now we have this x squared on it, and if you know about the quadratic stuff, whenever we have quadratics in there, we can't solve for x the traditional way of undoing everything that was done to x and isolating x. You can't do it that way anymore. So we have a new method, and what we're going to do is we're going to set this to 0. So we're going to go x squared plus 4x minus 21 is greater than or equal to 0. And all I did was I subtracted 21 from both sides, and then came up with that. You might be saying, well, why did 4x minus 21? You can't really do that. That's true. That's why I had to separate those 4x minus 21 and write it like this. Now you should recognize this as that standard form of a quadratic, and with that we could do two things. We could deal with the quadratic formula, b squared minus, might help if I knew the quadratic formula, right? Negative b plus or minus the square root of b squared minus 4ac divided by 2a. Or we can use the diamond. Now, if you can use the diamond to do this, to factor it, it's much simpler. So we're going to put b down here for the basement, a times c. Now, a in this case is 1. It's good. So a times c is the ceiling. And then we're going to look for factors of 21. 21 and 1, 7 and 3, and I think that's it. So obviously it's got to be 7 and 3, and one of them has to be negative to make this come out right. If I make the 3 negative, then that does check out that it adds to negative 4. I'm sorry, positive 4. All right, so what that tells me from the diamond is that this tells you that it's x plus 7 times x minus 3, and we're going back to the original equation, is greater than or equal to 0. All right. Now, we're going to basically at this point kind of pretend that this just says equal to. All right, and we're going to treat this and solve it to find the two, what I'm going to call dividing points. It divides up the number line into the correct solutions and the incorrect solutions. So what we're going to do is we're going to say, hey, you know what? X plus 7 either has to be 0 or x minus 3 has to be equal to 0. And the reason we said that is because here, look, you got two things that are being multiplied to give 0. Well, then you know what? Either this one has to be 0 or this one has to be 0. Now, what makes this one come out to 0? Well, let's find out. Most of you can just look at it and tell, but it's negative 7 would make it come out to 0. Likewise, on the other one, positive 3 would make it 0. So what that's telling you is, change pen color because I'm getting a lot of stuff here. It tells you on a number line that if you plot negative 7 and 3 on a number line, that you're going to divide this into correct answers and incorrect answers, and we just have to find out where the correct answers are. It's either going to be everything inside, or it's going to be everything on the outsides. You should be a little bit familiar with that. Alright, so let's test something. We're going to go pick on 0 here because it's easy. And we're going to plug 0 in to our original equation all the way back up here, in for x, and we're going to 0, 0 squared is 0, plus 4 times 0 is 0, so all that comes out to 0. Is 0 greater than or equal to 21? No, it's not. So, what that tells us is that this is not the solution area. So we're not going to shade that in. Alternately, this is the solution area, everything on the outside. Now, we're going to fill in these circles here because it's going to include -7 and +3 in this because of this or equal to part. Anytime you have greater than or equal to, you're going to include with solid dots. Less than or equal to, solid dots. Greater than just by itself, open circle. Less than, open circle. Alright, so that's our solution set. Now, how do you take that? Let me clear my screen. And we had -7, +3. We said it was closed and it was going this way, closed, and it was going that way. How do you turn that into one of these inequality statements? Well, basically that's saying that x is less than or equal to -7, that's this portion, or x is greater than or equal to 3, and that's this portion. So you just got to find that up here. These kind of things basically say that x is in between those two values. We found out that not to be true. This one we found out not to be true, so it's x is less than -7 or greater than 3. And here come the announcements. But it's a Friday, so maybe they won't have any announcements. Not a lot of after-school activities. Alright. Let's go to the next one. Sorry, it was kind of a long explanation, but unfortunately that's kind of what we need. Alright, this one, you'll notice that it's already set to 0. So that was the number one thing we had to do, was set to 0. And the number two thing we had to do was to factor it. By the way, if we could not factor it with a diamond, we could use the quadratic formula, and that would also give us those two answers we're looking for. In fact, if you are comfortable with the quadratic formula more so than factoring, you're welcome to use that. Either one will give you those dividing points that you're looking for. And we're going to factor it, and that's going to tell us what goes on the number line. And then we're going to, from the number line, we're going to test to figure out how to shade. And then we're going to turn that into our inequality statement. Inequality statement. Alright, sorry about that bad handwriting. Alright, so let's take a look at this one. Again, we got our A, B, C values already set to 0. Check. We're going to factor it. Diamond, basement, ceiling. A value is 1. We got 3 and 4 with the 3 being negative, so that comes out to this. X minus 3 times x plus 4. You guys are probably experts at that. We're kind of pretending it's equal to 0 at this point, and therefore we're going to find out that, hey, you know what, 3 would make this part 0, and -4 would make this part 0. So all we did was solve each one of those separately. Now we're going to go to our number line. So we did our factoring. Now we're going to go to our number line. We're going to plot these 2 points. You don't have to get all crazy with the numbers in between. We're just trying to say, hey, is it going to be on the inside here? What number could we test inside here that would be very, very easy to work with? Some people are going to say 1, but I'm going to say 0, and 0 just works so nicely. Check this out. Put 0 in here. 0 makes that 0, makes that 0. Minus 12, so the answer is -12 less than or equal to 0. Is -12 less than? I said or equal to, but just plain less than. Is it less than 0? Yes, it is. So that tells us that this is the solution set inside here. I'm going to do open circles this time because it doesn't say or equal to there, so I'm going to leave it open. Alright, and now let's turn that into one of these statements, an inequality statement. Anytime the answer set is in between here, like this, x is in between. Oops, there I go again with that, or equal to. That's the way it works. It's that one. So -4 on this side and 3 on the other side. That says that x is in between -4 and -3. And that's true. We tested 0. If you went out here, whoo, if you went out here and tested 10, for example, it should not come out true. And I'm just going to go put it in there. X squared plus x minus 12 is supposed to be less than 0. Well, that would be 10 squared plus 10 minus 12 is supposed to be less than 0. Well, that's 100 plus the 10 minus the 12. And I get 110 minus 12. And that comes out to, what, 98 is less than 0? That's not true. And we weren't expecting it to be true. And that's why it's not part of the solution set. Okay. Last one. Thanks for sticking with me. Oh, I said last one. All right, there we go. Now, the cool thing about this one is it's already set to 0. Number 2, it's already been factored. Because you might be looking at this one going, ooh, I don't know what to do. But it's already been factored. Some people are going to be tempted to use FOIL on it. But what happens when you use FOIL on that, you get to that x squared kind of thing. You have to turn around and factor it. So we do not want to use FOIL on this. It's already been factored, and it's in the form that we want it. All right, so we're going to go straight to number 3, which is deal with that. Find out. It's called setting it to not setting, splitting it up and trying to find out, solving each side of this little thing. So we're going to split it up. X minus 3 either has to equal 0, or 9x plus 4 has to equal 0. Terrible explanation there. Okay, so we're going to plus 3, and I know that you don't have to do that. You can probably do that, like without having to write that down. So you just, a lot of people say, ooh, just take the opposite of that. But watch, it doesn't work over here because this has a coefficient of the x squared term bigger than 1. So we really have to do it with this little equation. And we're going to divide by 9. So we get x equals, well, it's negative 4/9. We're going to leave that as a fraction. I want you to notice the answers have this negative or 4/9 and 4/9 and negative 4/9 in them, so that's okay. All right, and so those are our dividing points. And don't get nervous about that fraction. Watch what happens. We're going to plot it on the number line. 3 is on this side. The negative 4/9 is over here. Is 0 in the middle? If it is, and it is in this case, that's the one we're going to test. We're going to put it back in the original equation. And let's see what happens. I'm going to change to red pen so you can actually see what happens when I plug a 0 in here and a 0 in here. I get negative 3 times, and over here I get 0 times 9 is, well, that's 0, and then plus 4, so I get 4 greater than or equal to 0. That's negative 12 greater than or equal to 0. Is that true? No, it's not. Negative 12, a negative number, is not greater than 0. So it's not out there. It is filled in because it was or equal to, and it's on the outside. Filled in because it's or equal to and on the outside. So that's what we're looking for. So it's on the outside, so x is less than or equal to negative 4/9. By the way, notice this less than symbol is pointing this way, so is the shading. X is greater than 3 or equal to. Notice this stuff is pointing this direction, so is my or equal to, my greater than symbol. Alright, that's what we're looking for up here. Let's see if we can find it. Greater than or equal to 3, you probably already found it. There it looks like it is. Alright, that last one was probably one of the easier ones. Alright, have fun with it.